G'day. In this episode of the Oracle Mobile Application Framework online training, it is dedicated to discussing the data visualization tags, or DVT tags, that come along and are coupled with the standard AMX components. Previously, we explored the various AMX components available to MAF developers to use in building their mobile applications. Now, to be truthful, the most compelling mobile applications out there are those that utilize user interfaces with pictures, graphs, maps, and so on. In other words, they're visual in nature rather than just boring text. This is where MAF's DVT components step in. They're designed to allow users to visualize complex data and their relationships, not in raw text and numbers, but in pictures and interactive controls. Besides avoiding the boredom or too much text, the goal of DVT components is to help users comprehend the volumes of data available to them. And that's why DVT controls are heavily used in both analytic type applications and of course rich mobile applications you can build in MAF too. In context of the MAF DVT components, there are several categories of components available to you. The first set of DVT components includes lead gauges, status meter, rating gauge, and an inordinate amount of regular gauges, sometimes called analog gauges. The second set of DVT components are charts, which include area charts, bar graphs, scatter plots, combo graphs, funnel graphs, line graphs, pie charts, and series graphs, and much more. Finally, the last set of components, DVT components that is, we'll lump a whole bunch of them under one category. It includes geographic maps, thematic maps with custom markers, thematic maps with custom maps, the HRN box component, the timeline component, and the sunburst component. When learning to work with the DVT components, it's important to understand they are different from the standard AMX components. While DVT components are still built out of XML tags and they source their data from data sources such as data controls, because the data they represent is often much more complex than a single linear value, often involving multi-dimensional arrays, for beginners some of the DVT components are more complex to build and utilize when you're starting out. But not to worry, that's our job here, to try and reduce the learning curve. It's also useful to know that broadly speaking, DVT components themselves can be grouped into categories, where the components within each category have and define structures, properties and behaviors that are very similar. As such, once you learn one DVT component from each category, you generally have a good idea of how another component from that category behaves. So again, broadly speaking, DVT components can be broken into two sets of components, those that are fairly simple to work with and those that are relatively more complex because the data sets they require are complex and how they visualize that data is also complex. This can then be further split out into subcategories. In the simple category you have gauges, which are the simplest of all DVT components to work with, as typically they're based on a single value. Then you have charts, of which there is a large range available to developers, many of which you'll be familiar with: bar charts, pie charts, line charts. On the more complex side, there are maps, such as displaying Google or Oracle maps in a geographic map component, and thematic maps for displaying maps based around themes, such as economic data, sales, political structures, and so on and so forth. In turn, the hierarchical DVT components, such as the sunburst and tree map components, require a fair amount of experience with AMX to use, as they require multi-dimensional arrays to represent hierarchies of data. And finally, we have some miscellaneous components, such as the timeline and N-box components, which have some interesting data requirements too. Once we understand which category a component fits, this will make the learning curve easier, as DVT components within the same category are very similar in operation and use. The next thing to understand about DVT components is there's essentially 5 things you need to consider to build a successful DVT component for your MAF application. This can be expressed as a simple formula. That is, the runtime DV component, its visualization and behavior is defined by, at design time, the DVT component XML and its properties, plus the data that the component shows, and any optional children XML components you define for the DVT component, plus any optional custom styling you add to the component, and finally, any optional events you add to the component to add additional behavior. So with this simple formula, let's explore some of the DVT components in each category so we get an understanding of what needs to be built. For something like a DVT dial cage, which is a relatively simple component, it requires a single value, either a hard-coded value or a value derived from a bean or binding as shown here to show its results. Yet, if we consider a chart, for example, say a line chart, it requires not just a single value, but many values to plot a line as a series in an XY axis graph, and then even multiple series to plot several lines in a graph. Unlike the simple dial gauge component, for charts, those series of values are best represented in an array. As we can see here, my bean includes an accessible array containing the values the graph requires. This array can be accessed via the line chart value property. Then for every element in the array, the value series, group, and values are then plotted in the graph to produce the end result. Now, admittedly, that's a bit too brief a summary for charts. So let's go a little deeper into understanding what a chart plots and what the chart requires to plot in terms of data between the X and Y axes. In understanding both of these, it then becomes easier to build chart components as they all use the same mechanism. So here we have the same line chart as we saw previous. The XML component on the left, the actual component rendered on the right. Note that the line chart includes a named facet called data stamp. This is designed to take the data from the line chart value property, our array in this case, and stamp out every data element in the line chart at runtime using the chart data item child tag. For a line chart, each data item represents one value in a series, and a series is essentially each individual line in the graph. Then in addition, the group or x-axis value for each data item. And finally, the actual value plotted against the y-axis. In this example, just the values for the first series are indicated on the diagram with arrows, but all series and values are valid. Now we understand what each element in the array needs to include. This gives us an idea of how the array must be structured. Essentially, the array we plot into the line chart value property is comprised of elements containing a value for series, groups, and values. For the first element in the array, it maps to series 1, group A, and value 74. At this stage of drawing the graph, there will be no line as only a single value 74 will be known for series 1, and the x-axis would only know about group A. For the second element in the array, it maps to series 1 again, group B, and 63. At this point, as the graph now has two items in series 1, it would draw a line between them and also expand the x-axis to include group A and B. For the third element, series 1 group C, value 70, the series line is extended and so is the x-axis. Ditto the fourth element, ditto the fifth element. On the sixth element, a new series number 2 is discovered, so any new values won't be plotted against the original series 1, but a new series will be started. And so on and so forth to plot the rest of the series lines and values. So you might ask at this point, how does the line chart know to print the series lines in different colours? Or could we change the weight of the lines or the style or plot different shapes at each value and so on? In other words, how can we style a chart? This is where we introduce another facet of the line chart, series stamp. As you can see from the series style child embedded in the series stamp facet, you can now influence the styling of the series, such as the color, line width, line style, are markers displayed for each data item and is the line rendered. Also, as you can see, these values can just be additional elements derived from the array. Further to that, charts can include additional children, such as those to include and stylize a legend, as can be seen on the right-hand side of the graph, as well as how to stylize the X and Y axes of the graph, such as showing or hiding the axis lines and ticks. Phew, so at this point we're really getting wrapped up in the tags, and it would be nice to sit back and watch a demo of an actual chart being built to solidify our understanding. Let's have a look at building an actual page now. In our demo, we set up a class line data, which will represent the individual points in our line graph, with member variables group, series, and value. You can add additional variables to this class if you want to display other items with each value in the series. As you can see, the line data class includes the relevant constructors and accessor methods to access the private member variables. In addition, we had the line data list class, whose constructor has set up some hard-coded demo data for us by populating an array line data list comprised of the line data instances. This class is configured with the appropriate accessor methods to access the list too. As we've seen in the previous episodes, we'll create a data control in this class. After which we can see the line data collection exposed through the data control palette. Now, within our page where we want to show the line graph, we drag the line data collection from the data control palette into the page, select MAF chart from the displayed dialog, and within the component gallery dialog, select the appropriate DVT control. We want to show a line graph and we want to include a legend, so this is the most appropriate option. In the Create Mobile Line Chart dialog, we then need to define which attributes of the line data collection, that is group, series, and value, map to the line graph line and x-axis. We do this by dragging them into the associated fields. On returning to the page, you'll note the line graph component has been configured for us, where specifically the group and value have been configured and are correct. Unfortunately, the series property is wrong because the previous dialog didn't give us the ability to define the series. As such, we need to fix this property to map to the row.series from our line data collection. As the series attribute isn't available in the bindings, we need to access the page's bindings and include the series as one of the display attributes. Then, back in the page, rewrite the series property to access the row.series binding. Next, we want to define what the series looks like, so we drag in from the MAF AMX data visualization components. From the component palette, we drag in a series style component into the series stamp facet. And finally, we define the color of each series. Now, just for the purposes of demonstration here, I'm going to cheat. As I know the data collection includes 5 series, I'm going to hard code the 5 series where the first line is red and the rest are black. You can change this such that each series color is derived from the data collection line data, but you need to include an additional member variable to store the color and access it via ELL in the series style tag. Finally, we'll leave the legend tag in so the line graph shows a legend for the series colors when the graph is displayed. So there you go, the basics of DVT components. As you can see, it's as much about learning about the data structures that they require as much as the XML tags themselves. In the next episode, we're going to look at more DVT components, specifically maps. Thanks for your time today. Hope to catch you in that next episode very soon.